Altitude hold.
Motors on.
Right, so I tried a brief alt hold hover and the thing shot into the air. So that tells me that the hover thrust is wrong. So actually we have a log you can look at, my initial log. So let's have a look at this log again, this one. And if I look at C-turn throttle out, you can see that hover thrust is 0.145. Whereas this, it hasn't learned one, so I think that's the problem. So I think 0.2 is, so it's trying to hover at a much higher thrust, so I actually want it down here at 0.145. So let's set that up. So we go to MOT thrust, hover, 0.145, yes. Still not sure about this expo value, seems a little bit dodgy. And then the other thing I want to do is so these P and I, P should be the hover thrust, 0.145, and I should be, okay, so won't let me do it there, so let's go to PSC, this guy, XZP, so this is 0.145, and this guy should be double that, 0.29. I mean, they're quite low, so probably need to be a little bit higher than this, but it's sort of right ballpark. And then I can try a hover again. So let me just try that. Alright, didn't shoot into the air quite as bad, but it still was pretty aggressive. So let's see if we can work out what's going on here. So there should be a log. Down, whoops, connect my drone. Download a log. Let's get this one, 14, okay. Logs have got corrupted. Right, so let's clear logs. No good. All right, so I'm gonna have to run that test again. Guess we could have a look at the other log. In stabilize, just to see if there's anything obvious going on here. In particular, what does it think about the height? She's under C-ton out. So yeah, okay. So I think the issue here, the issue here is basically there's no foam over the barrow. And so we get massive prop wash, and yeah, so if we look at, let's have a quick look at that. There is a website here for the flight controller. There we go. This guy. So the barrow is here, right next to the battery on the chip side. So if we have a look, if we go over here and have a look, so right, so we can see, I mean, there's no foam anywhere near there. So I think what I might be able to do is just stuff some foam in there near the barrow, and that might make enough of a difference. So I'll try to find some foam, just see whether that will work a bit better. Right, I've taken the battery off and I can literally see the exposed barrow just in there. You probably can't see, but it's just under there. So definitely need to get some foam in there, ideally without having to deconstruct the whole thing, but I reckon I could just stuff some foam into that gap and that might work. There's a capacitor lead that's slightly obscuring things, but let's try that. Alright, so I've stuffed a little piece of foam right over the barrow underneath the wire, and then I've stuffed another bit there into that little corner there, and the battery should kind of keep that on. I could put some tape over there, I suppose, if I really felt like it, but I think that'll do for now. Hopefully I won't lose that, but a bit of tape might not go amiss there. So I'd give it another go. Okay, did another little test flight, just this time in all hold. So first thing to check is the throttle. And I went a little bit higher, so you can see throttle here is 0.18. So I think my first flight was too low to the ground and I was sort of benefiting from ground effect. So 0.18 seems more likely. So I'll reset that. And then if I look at the altitude, it's much better. So it's centered around 0. We don't get this big bump on takeoff or landing. It still thinks I got 6.5 meters in the air, which is not correct at all. So that seems a little bit strange. So I don't know why that would be. But certainly that is much more reasonable. The other thing I just wanted to check was is this configured correctly for, is the battery configured correctly? So 11.7 volts down to 11.1, that's probably roughly right. Current is 16 amps. That seems unlikely to me on a copter that small. So my guess is that the current setup is wrong. So I'll go and have another look at what the scale is set on Betaflight, because I suspect this is the wrong setup. So I might just adjust that. But the current shouldn't affect, it's the voltage that affects the PID scaling, and the voltage looks approximately correct, so that should be okay. So I might just adjust the current scaling. Let's adjust the thrust hover. Make that point. Which one is 2 there? 0.18. Right. Let's switch off hover learning. And then let's adjust these PSC parameters again. So this is 0.18. This is 0.36. All right. So I think that's good to try and hold again. I've had a few indoor crashes with alt hold where it shoots up into the air. Let's see if I can get this working a bit better. Oh, the other thing I wanted to check was it was tending to drift sideways. Let's have a look at this log again. So I'm guessing so what is the IMU? What does it think about the accels? Well, it'll look pretty good. Z is roughly at 10. So okay, so what is the EKF learning then? So we'll look down here. One of these, I can never remember which one. Okay, accelerometer bias. It's learning, okay. These are in meters a second, so it's learning this enormous Y offset bias of 1 meter a second, so no wonder it was drifting sideways. So let's not do that. That seems wrong to me. And there should be a G bias equivalent. Yeah, similar. So the EKF isn't in a great position to estimate these anyway, so I know I've done a good temperature calibration, so what I'm going to do is turn those right down. So if we go to our config, EK3, is it G bias? G bias P noise. Increasing it makes rate gyro bias estimation faster and noisier. So I'm going to divide that by 10, 0.0001. Okay, and then I'm going to do the same for the acceleration. EK3A bias. Faster and noisier. So I'm again going to divide this by 10, 0.002. Let's do that. Oh, and I just want to check serial 4. Yeah, serial 4 set up. Display port. That's good. All right. So I'll try that hover again and then try one in alt hold if that looks good. Alright, here's another log. So let's have a look at the throttle. So you can see I did stabilize followed by alt hold. So alt hold still shooting in the air a little bit. And that's partly because of this whole, what's going on here business. Whereas the barrow altitude is really quite good. I mean, a bit overly cooked, but the barrow altitude is much more accurate than the actual estimated altitude. So EKF not estimating altitude very correctly, so I need to figure out how to fix that. And then the other thing was the IMUs. So let's have a look at these bias estimates again. Okay, still pretty large, pretty large. Why are they? Why is that growing so quickly? Seems very strange. Unless it's something to do with temperature calibration, I don't think it can be. Okay. These also learning very, I mean, this is from when it bounced on the ground, but yeah. All right, so some more EKF things. So let's just check our EK3 source. What's this? All right. Okay, Alt M noise. Well, that looks promising. Increasing it reduces the weighting of the barrow measurement and will make the filter respond more slowly to barrow measurement errors. Make it more sensitive to GPS and accelerometer errors. Larger value may be required when operating with EK3 source X pos Z equals 0. Right, we're using pos Z is 1, not using this 0. So I think making this, let's divide by 10. I think that's a good place to start. And what I don't understand is G. It's just, is there only one A bias? Yep, a little bit out of my depth here. So in this one, G bias, so what's this guy? Change the bias. probably want that to be lower. P noise, A bias P noise. Okay, I've done that one. G bias P noise, done that one. Growth of the estimated error due to gyro. Increasing it makes the filter trust the gyro measurements less, other measurements more. We only have one other measurement, which is the Baro. So I think I'll stick with that. Let's see whether the altitude P noise made any difference. I should be able to tell just in stabilize without risking the copter. All right, let's try that. All right, so another log, still don't seem much closer. So look at this one. Look at the altitude versus the Baro altitude. So you can see the altitude is not bad, apart from this enormous lump here, which is of course causing lots of issues. I don't know what's going on there, but interestingly it corresponds to the height. You see the height innovation shoots above 1 here. I don't know what's causing that. Maybe it's sort of acceleration on, I guess acceleration on takeoff maybe, but this is back here. So I just, yeah, I don't fully understand what's going on here. What would be nice to see is a graph of the estimated inertial height versus the Baro height. That might tell us. I just don't think there's a way of telling that. So anyway, I did find, there was another setting I did find which I use with my GPS setups, which is this glitch radius. So although this applies to the GPS, it also applies to the POS eye gate. So let's set this to 0. If I look at POS eye gate here, okay, no, let's set that to 0, but there's a height eye gate as well. Here we go, which also is affected by glitch radius, you can see here. So I'm going to set the height eye gate to 300 here. And do another little test just to see if I can figure out what's going on there. Alright, let's try that.